Hello, everyone. This is Colleen Milton, and on behalf of Platform 9 and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled, Effectively Deploying Kubernetes on Hybrid Cloud. Leading off the discussion today will be Jay Lyman, who is a Principal Analyst at 451 Research. Following Jay will be Suresh Raghuram, who is CEO at Platform 9. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen below. We will answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download. And finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to Jay.
Great. Thanks, Colleen. And thanks, everyone, for joining. Today, we're going to provide a bit of an overview of the Kubernetes and cloud-native market and ecosystem, including what's driving use, the key hurdles, and how it all relates to hybrid cloud. We'll also hear from Platform 9 about putting Kubernetes into action and how containers, Kubernetes, and services-based deployments work in the real world. So just discussing the Kubernetes landscape and market, I'll be going over some data indicating that cloud native has become a priority for large enterprise and service providers, and mostly driven by speed, efficiency, and competitiveness, but we'll go over those drivers in more depth. We'll also discuss in more detail how containers, microservices, Kubernetes, service mesh, and serverless all coexist on what we call the spectrum of abstraction. In terms of standardization, we have seen mixed use of container management and orchestration software, but the industry is really standardizing on Kubernetes. And we've got some recent survey data showing strong adoption of Kubernetes, which I'm sure comes as no surprise to anyone, but it's always good to quantify these things. We also see enterprises moving beyond do-it-yourself. Even this is how containers and Kubernetes are typically adopted by organizations that have teams of developers or DevOps that sort of stand up and get Kubernetes running. It's pretty common that they run into problems once they scale up, once they move to production. Thus, we see organizations moving to Kubernetes distributions, supported distributions, managed services, and basically supported offerings where they have vendor SLAs and vendor support. And then final note here in the tie to hybrid cloud infrastructure, beyond being just a container management and orchestration software, Kubernetes is a distributed application framework. And this does make it ideal for hybrid infrastructure, which is also growing. And we see some good timing there for Kubernetes. Just looking at some of the priority on cloud native here, we see cloud native technologies, containers, container management and orchestration, and serverless showing up in the top technologies on the radar for 2019. Combined container category and serverless is 33%, second only to data analytics tools and platforms, which are among the adjacent trends growing with cloud native. We see machine learning and artificial intelligence also ranked high here. And this highlights the interesting crossovers of adjacent trends with cloud native, things like Kubeflow and containers for data scientists. And what we typically see is the combination of containers and ML, AI can enable data scientists to create and train models in self-contained environments with the necessary data and dependencies, and these can then be deployed into production via Kubernetes, which provides auto-scaling, failover, and infrastructure monitoring and management, as well as exaction venue abstraction. So some real synergies with some of these other trends that are also priorities in the enterprise. So the spectrum of abstraction, this is sort of our answer to the false narrative that serverless is killing containers. Some of my other favorites are that containers are killing DevOps No, we see containers as another tool for DevOps. Containers are killing VMs. No, we see containers actually running on VMs pretty commonly. And we also see coexistence of containers with VMs. Kubernetes is killing Docker. This is another one where Docker is a critical component of nearly every Kubernetes implementation on the planet. And then another one is that superlatives are killing analysts. And that one might be most accurate. But in terms of the idea that serverless is going to kill containers, to the contrary, serverless is actually built on containers. And we see these technologies used in tandem. No one is dropping their containers in microservices deployments for serverless. They are adding serverless to what they're doing where it makes sense, but nothing is completely replaced or displaced most of the time. And on one side of the spectrum is more of the do-it-yourself containers approach, whereby organizations leverage custom code and services and make their own choices on languages, frameworks, and APIs. On the other end, and that's where it makes sense. That approach is attractive for certain applications that require low latency or that run longer compute jobs or for which traffic can be predicted. On the other end of the spectrum, as functionality becomes more abstracted and invisible, we have serverless functions and events for which there are standardized and opinionated choices that are abstracted away from the end user. And in between these two ends of the spectrum are still other levels of abstraction, such as supported Kubernetes distributions, managed services, and container as a service offerings from the large public cloud vendors and others. But the point is that these technologies build upon one another and they're used commonly alongside one another. And there is no exclusivity to one or the other. In looking at container adoption, this follows a pretty steady trajectory of growth. Last year, this was more of a 50% using, 50% not. This year, we see about 56% of companies using or planning to use containers within the next 2 years. Another 15% considering. Fairly high, 28% not in use nor in plan here. But in a separate survey of DevOps savvy companies, it was fewer than 3% that were not in use. And 95% of those DevOps using organizations were using containers now or planning to use them within the next 2 years. And I expect this general adoption depicted here will increasingly mirror what the DevOps savvy companies are doing. And we'll see continued growth of the in-use and the planning categories. When we look at the level of adoption of serverless, we see it's fairly close behind containers, which is impressive given its maturity in the market. It's still, I think, early days for both containers and serverless, but even more so for serverless. Nevertheless, we see 36% of companies in use or discovery proof of concept, and another 7% planning within the next 2 years, and another 21% considering, with 37% not in use or in plan. And this is pretty much what we saw for containers around about 2 years ago. So I'd expect it to grow on a similar trajectory. And I'd also point out here that we tend to generally see a chronological order of adoption of these technologies. Generally, it starts with containers and microservices. Then organizations are managing Kubernetes or container clusters with Kubernetes. And then we see them getting more into serverless or service mesh, which is even earlier days, but is, I think, often seen as, rightfully so, a good solution for microservices. And we'll see growing use of all of these, I think, over time. In terms of standardizing on Kubernetes, again, as I said, we have seen mixed use, but we do see a standardization occurring in the industry. About 84% of organizations are standardized on Kubernetes. and they indicated it will take them 1 to 3 years to get there. Again, in that DevOps savvy audience and survey that I referred to earlier, and it's a more recent survey, we see some impressive Kubernetes adoption there, with 80% of enterprises using or planning to use Kubernetes now or within the next 2 years. And so we do see this standardization occurring. You do still see mixed use of some of the other technologies, and that makes sense. Sometimes that's technical, and sometimes that's what organizations were using before Kubernetes arrived in the market. Docker Swarm is tied to the container engine, so that makes sense for organizations just starting out. Technologies like Mesos and Mesos for DCOS have ties to big data technologies such as Apache Spark, Hadoop, and Kafka, and also big data applications. Nevertheless, we do see this move towards standardizing on Kubernetes. So what's driving containers in Kubernetes? I think that containers in Kubernetes are most frequently associated with developer speed, developer efficiency, developer onboarding, and developer enablement. And most enterprise organizations are working pretty hard to better serve their developers and to enable some of that speed. For IT operators, it's more about consistency and efficiency, managing larger scale infrastructure with a smaller number of people. And we're also seeing cloud native and DevOps gain traction through their attachment to digital transformation. There's certainly a lot more top-down adoption of DevOps and cloud native, and organizations see that developer enablement and speed all as parts of digital transformation and being more competitive in this highly dynamic market. And here we're just looking at sort of the speed benefits of containers. The top answer here is days reduced to hours, then weeks are reduced to days, and pretty high percentages for hours down to minutes. And I think this sort of highlights how far we've come, from monthly or quarterly wait times for developers to get their infrastructure and the environments that they need. But not in every case. You still hear about 3-month waiting periods, even at seemingly progressive or cloud-born or web-scale organizations. And the point is you do need to serve those developers, or they'll probably go around you and get their own public cloud environments, and then you can sort of end up with this shadowy IT, which is a little different than shadow IT, because I think the developers are more aware that at some point this is going to have to be sanctioned and above board, and certainly the IT operators are cognizant of the fact that they need to better serve those developers and enable them to move faster and provide them what they need. So we generally see, although organizations want the software that they're using to be sanctioned and blessed by the organization, there is much more willingness to give developers the choices and the flexibility that they want and need. Looking at some of the other benefits of containers, beyond speed, here we see some of the other advantages highlighted. Consistency is big, as we see consistent development life cycles and standardization of development environments ranked high among the benefits of containers. Isolation and improved security are also pretty consistent drivers and benefits of containers. Security is a little tricky because it's also viewed as a challenge, but there are security advantages in containers, mainly around the isolation and the reduced attack surface from a more lightweight application package. And we also see portability as a big benefit, and we'll discuss how that portability is fueling containers and Kubernetes with hybrid clouds and hybrid infrastructure a little bit later. In terms of challenges or hurdles, particularly for Kubernetes, complexity seems to be the top hurdle. And that comes amid a lack of Kubernetes skills, experience, and expertise in the market. Once you install and stand up a Kubernetes implementation, again, making the jump to production can be challenging because of scale, monitoring, troubleshooting, and other sort of day two issues. And then there's also general resistance to change and sentiment that current processes and technologies are sufficient. So if it ain't broke, a lot of people don't worry about fixing it. And this sort of highlights also that as fast as software such as Kubernetes is moving, and as fast as the pace of innovation is there, enterprise IT tends to move slower. And this is why we see organizations wading in with the do-it-yourself approach. This is why we see containers running on VMs, because you're able to give those developers the containers and still have your tried and true VM process. And there's good tooling, management, and security around VMs. And let's face it, VMs are sort of the currency of enterprise IT today. So this is why we don't think that containers are going to be wiping out VMs. We do see coexistence. And just like we still have mainframes and physical servers next to today's VMs, we will likely have containers next to our VMs in the future. Or I should say VMs next to our containers. And we do see that disruption growing. Sorry, had a little bit of a technical glitch. So in talking about the challenges, one of the big ones is that sort of talent and expertise gap. And in terms of skills gaps, cloud-native programming and other cloud skills are among those in shortest supply, according to our survey data. And we can see how this has grown dramatically from 2016 to this year. And that corresponds to that growth of containers, Kubernetes, and serverless that I went over earlier. Looking at the other hurdles, we see here the top challenges with containers tend to be security, compliance, and regulatory concerns, which are common impediments to any new technology. We've seen this before with general adoption of cloud computing. I think it holds true. These are top priorities for organizations, and every time there's a security breach, that sort of drives more attention on this. The complexity, again, I mentioned previously. I think that's a big concern, and particularly Kubernetes represents a new way of doing things. So that does present some complexity for organizations. And here we see production use and the fact that the existing VM process may be sufficient. And these are pretty consistent across the different job titles and the stakeholders who are weighing in. So in terms of the relationship between Kubernetes and hybrid cloud, again, Kubernetes is a distributed application framework in addition to being a container management and orchestration software. So this does make it a good fit for hybrid, and it's well-timed with growing use of hybrid infrastructure among enterprises and service providers. And we saw good timing for Docker with general adoption of cloud computing. And we also see the same type of good timing with Kubernetes and hybrid cloud. With Docker, it was sort of how do we package and deploy these applications in the cloud? Well, this Docker container makes sense. Kubernetes as a distributed application framework provides a lot of those portability benefits. And that is a big thing, again, fueling use of containers and Kubernetes in a growing number of hybrid environments. And this slide sort of just illustrates how cloud native is very much, it does mean hybrid cloud in many cases. Cloud native apps are mostly designed to run on any cloud or any public cloud. More than half of respondents here were either one of those two categories, 54% of them. And then containers and Kubernetes enable portability of apps across all of these different deployment venues, all of which are important to organizations. It's not just public cloud that they're focused on. They are focused on private cloud as well as focused on on-premise infrastructure and allowing those to work together. This slide just sort of indicates well more than half of organizations moving toward hybrid environments. Another 9% in sort of this multi-cloud reality. I expect those will likely move more toward the hybrid infrastructures. And the whole point of this is not to make IT operators' lives hell. It's about what we call the best execution venue, running applications on the best infrastructure based on cost, performance, data sovereignty, geographic location, and other factors whereby there are going to be different infrastructures that make more sense in different cases. So we definitely see hybrid cloud growing, and I think that it's a big part of what's fueling continued growth for containers and for Kubernetes. And so with that, I'm going to turn it over to Suresh, but I'll be helping to answer questions at the end.
Thank you, Jay. Folks, I'm really excited to be talking to you today about Kubernetes and how it plays into the hybrid cloud journey. I'm co-founder and CEO at Platform 9. As many of you may know, we're a cloud computing startup founded by early engineers from VMware. And we offer capabilities around hybrid cloud management, which I'd like to introduce to you. The big problem that we see, and as Jay has alluded to, is that running Kubernetes in an enterprise organization at scale is a huge operational undertaking. And the complexity involved in running Kubernetes in initial pilots is very different from what it truly takes to offer production support. So one of the slides that Jay just presented, which said a lot of companies, 62% of companies, are looking to run on-premises and public cloud environments managed in an integrated fashion, and often Kubernetes is at the forefront in that technology choice. But in order to do that, you now need to integrate Kubernetes across multiple environments. You need to integrate it sometimes across bare metal. Sometimes organizations have a lot of VMware deployments. And depending on who you are, you may have a different cloud provider of your choice, or there might even be multiple cloud providers. And so now the integration complexity of supporting Kubernetes goes up. And new technologies around the Kubernetes is becoming this kernel for new and emerging technologies in the cloud-native ecosystem. A few years ago, we used to be talking about, the emergence of Docker, and then we started to see Swarm versus Mesos versus Kubernetes. Now all of that is gone, but around Kubernetes, you have monitoring systems like Prometheus, you have service mesh technologies, you have open tracing and Jaeger, and so and there's a growing set of technologies that are available which add value for companies that are going down the cloud-native journey. And ultimately, these become requirements at some point to support those in production as well. So the need to support a growing set of technologies is always there. And these technologies also have new versions coming out constantly. So Kubernetes has a significant new release coming out every 3 months or so. That's not counting patch releases. And for some of you who might be using Kubernetes, you might know that the Kubernetes API, backward compatibility, is only guaranteed for one release, which means that if you don't keep up with the release cadence of Kubernetes, it becomes progressively harder to catch up. If you fall off that train of Kubernetes releases because you're not able to upgrade it because you don't have the kind of operational infrastructure needed to upgrade Kubernetes, it becomes progressively harder to catch up. And so then you're in a vicious cycle where you can't catch up. And so the kinds of teams, the operational complexity that is involved, the kinds of team and talent that is needed to support this is really, really high. So you need, typically a really sophisticated team of Google SREs. Now the challenge is that the most valuable SREs, as Jay alluded to, that is one of the hardest skill sets to hire in the market, and typically they have a lot on their plate. And so that is the most common problem that we see enterprise customers have. So we address these challenges with an operational model which leverages machine operations, and it's provided as a service, and which means that we, Platform 9, provides a Kubernetes service with a guaranteed SLA that runs anywhere. And so if there's a problem with your Kubernetes environment, it's on us. If there's a problem with etcd failing or a cluster kind of losing consistency or losing its masters, that's on us. If there's a problem with rolling out an upgrade, that's on us. Upgrades are deployed remotely and patched. Security incidents are patched remotely. Some of you who might be running Kubernetes might recall that there have been a couple of CVEs in the last quarter or two where it was a pretty significant security vulnerability, and a lot of companies were scrambling to try and find a way to patch their environments. And so we offer all of that by providing this as a service that runs anywhere from bare metal, VMware, public clouds, or any infrastructure of your choice. So it's infrastructure agnostic. And it's one Kubernetes distribution that's based on Upstream, stable, and it's the SLA that Platform 9 provides. And the way we're doing this is really, instead of throwing people at the problem, we are throwing machine operations at the problem. So it's paradoxical. If you step back and think about it, Kubernetes, one of the biggest reasons why organizations are interested in Kubernetes is because of how much automation they're able to derive from Kubernetes, and ultimately they're able to do more with less. But Kubernetes operations and management, if you try to do that with people and with off-the-shelf tooling, which isn't really fully curated and maintained by any one big entity that is really investing in it, then you still end up with this problem where you're trying to throw people at a very complex problem. In contrast, what Platform 9 does is we are using machine operations so that we have systems that instrument a full Kubernetes stack. It's Upstream Kubernetes that we instrument and we monitor 24/7 by 365. We ensure that our systems are monitoring the availability of your Kubernetes clusters. They're monitoring for diagnostics, preemptive signs of trouble, and we have a whole cadence of alarms that get triggered via automation. And ultimately, some of these may need to be seen by one of our SREs. But the idea is that to really apply machine operations at scale. And so we're now managing 500,000 cores of compute worldwide, and about a third of them are running Kubernetes clusters. And so that is just to convey to you the scale of operational efficiency that Platform 9 brings, whether this is running on premises or in the public cloud or any cloud provider of your choice. So going back to some of the challenges that enterprises face with running hybrid clouds, what Platform 9 does is it gives you, because of this as-a-service architecture, you kind of don't need to worry about these different silos that end up happening. Most companies that end up having multiple cloud or data center environments end up having pretty siloed experiences and pretty, what feels like completely different islands of infrastructure with dedicated tool sets and different ways of operating the tooling and different ways of building applications and operating and supporting those applications, which as an organization grows and adopts more and more cloud technologies, there's a massive cost and inefficiency associated with that. What Platform 9 is doing is it's providing a centralized, single, consistent way to manage and control and orchestrate infrastructure, no matter where that is, whether that's in the public cloud, whether that's on premises, whether that's in edge environments. And that in turn means that you have that consistency to control and operate across all of these environments without having islands of infrastructure that have completely different tool sets and require completely different skills and offer disjoint experiences to developers and DevOps users within the organization. And so ultimately, that model reduces the total cost of cloud and the unit cost of cloud, drives up utilization and effectiveness in terms of how effectively how much value you're able to derive per dollar of cloud spend, and reduces the need for shadow IT because developers are able to get a better experience no matter where that environment is, and no matter how IT Ops is trying to provide policy around it. We spoke about how new versions of Kubernetes are coming out all the time, from patches which come out more frequently to significant new releases which come out about once every 3 months. So with Platform 9, the console provides a notification when a new curated version is available for upgrade. So Platform 9 itself is about, we're within 2 releases of the latest Kubernetes release. We're rarely on N. Let's say that the latest release of Kubernetes is N. We're rarely on N, but we are almost always at N-1 or N-2. So today, if 1.13 is the latest version of Kubernetes, we are at 1.11 going to 1.12. So that allows, and these upgrades are deployed by Platform 9, but customers can opt in, administrators can opt in into the upgrade on a per cluster basis. And you can it's just a point and click experience. There's also an API for it. And that cluster is then, the upgrade is orchestrated in a very careful manner, which is non-disruptive to the applications that are running there. So nodes are progressively drained and then upgraded, and then it's an orchestrated rolling upgrade across the rest of the cluster, which ends up being non-disruptive to the application stack. And because we're keeping Kubernetes up to date, you have the ability to kind of ensure that your applications are always compliant and using, or your automation is always compliant and using a supported Kubernetes platform without any disruption to your workloads. We spoke a little bit about this, but what you get with Platform 9 is not some kind of custom distribution of Kubernetes. It's kind of paradoxical in the open source world to have this notion of a distribution and somehow one distribution supposedly being marketed as being better than a different distribution. And that kind of defeats the whole point of open source. Right? The whole point of open source is to collaborate and reuse and share and contribute. And so that value is highest when you're at Upstream Kubernetes. So what Platform 9 does is we take the Upstream Kubernetes releases and we are just providing machine operations as a service for that Upstream Kubernetes. And we are providing an administrative experience that makes it easy for you to integrate it with any of your environments, any infrastructure that you have, run a variety of applications on it. And this also means that emerging extensions to Kubernetes that are very much a part of the cloud-native ecosystem, such as Prometheus, such as Istio, and there's a broad range of data services and other applications that are certified and curated versus Upstream. They just work right out of the box because we are Upstream Kubernetes. There's no changes between Platform 9 and the Upstream code. Occasionally, when we run into a bug or an issue, which is a bug in Upstream Kubernetes, and we have to fix that to ensure that the customer is not impacted by it, we have the ability to make that fix, but it'll go back upstream. Or if it's not a time-sensitive issue, we'll make that fix upstream and let it come back into our version of Kubernetes when we pick up the next version from the Upstream code. A lot of users in Kubernetes are now using Kubernetes beyond just the core compute platform for stateless web applications. There's a broad range and a growing set of application stacks that are available from within the cloud-native community. Any number of these. For example, there's databases like SQL databases and non-SQL databases and new SQL databases. There's streaming data platforms like Kafka. There's operational tools like serverless platforms like Fission and Kubeless and others. There's a broad range of technologies that the community is building using Kubernetes as a common platform that runs on infrastructure anywhere. And these technologies ultimately are very interesting for developers and DevOps users to consume. And in many ways actually represent a new era in cloud where previously to get a broad range of cloud services, you had to go to use one of these public cloud providers who obviously offer some really compelling services, but all of these different cloud providers are different. And so the challenge is how does the community get an experience that's more consistent, it's portable, and can run anywhere. And so that catalog of applications that's available in the Kubernetes community is available through Platform 9 using the Helm stack. And it's also something that we are looking to augment our machine operations to add value to. So, for example, we're actually adding Managed Prometheus, Managed Istio, and Managed SQL this year to our platform, all by augmenting the Helm application catalogs that are already available with operators, Kubernetes operators, and with the machine operations that Platform 9 has. So Platform 9 is, in a nutshell, to recap, is the industry's leading Managed Kubernetes service, which is truly backed by machine operations, has truly a guaranteed SLA around it, financially guaranteed with service credits and clear terms of ownership, and runs anywhere. So use it with your existing infrastructure, use it with your public clouds of choice, and bring your own infrastructure, new or existing. And we have, many enterprises across the community are making big bets on our hybrid cloud platform, including some really exciting logos that I'm sure you'll see the press around in the coming months. But these are customers, Autodesk, Veritas, Providence Healthcare, Aruba, and others are customers who have been with us and have had, they've gone through the journey that Jay alluded to, where the Kubernetes and container journey began in developers, and they saw value. They started to learn how to package applications using containers, and eventually they went into a DevOps team, a Cloud Ops team, or an IT Ops team that needed to support it at broader scale. And all of these companies are using our Kubernetes solutions to drive their hybrid cloud transformation. So with that, I'd like to turn it back to Colleen to moderate Q&A.
Thank you so much, Jay and Suresh. It's now time for our Q&A session. As a reminder, simply type your question in the Q&A box on your screen, and we will get to as many as we can. We did have several questions asking if the deck was available for download, and it is on your screen under Resource List. You should see the webinar deck as a PDF, so feel free to download that. So our first question, can you please explain how Platform 9 SaaS offering compares to the benefits of using a managed service from one of the cloud providers?
Yeah, that's a great question. I think the architectural model between Platform 9 and these cloud providers is common. I think we're very similar to them in that we both use machine operations to run Kubernetes. So when you go to Google Container Engine, for example, you get a service where you can just sign up and you can start consuming Kubernetes clusters, deploying Kubernetes clusters, and consuming Kubernetes as a service. Platform 9 gives you exactly that same experience, but unlike the public cloud provider, it runs anywhere. So it can run on-prem, it can run in a hybrid fashion, but there's also a few more differences. So that's the similarity in that we're different from what you'd consider a traditional distribution of Kubernetes or other operational toolkits for Kubernetes. We're very similar in terms of the operating model for Kubernetes. We are very similar to GKE, for example. The differences, though, are very significant. There's some Kubernetes services that I think have a long-established reputation of being very stable and reliable. For example, GKE is an example of a service that I think customers have had a pretty good experience with. But there's others where I think I've heard from customers that it's been less consistent, not quite there yet, and there's sometimes not even an SLA. In fact, there's an explicit non-SLA for Azure's Kubernetes service saying it's a free service, there's no SLA around it. So Platform 9 gives you a consistent SLA no matter where you run. Secondly, we're very focused on Kubernetes. So for the public cloud providers, Kubernetes is a tool in the box, and there's a broad range of services around Kubernetes. And as you consume Kubernetes as a core kernel, but if you write your applications to consume their monitoring frameworks and their data services and so forth, essentially you're still not truly portable across. In one of Jay's slides, there was a slide about a desire for being portable maybe in architecture. Even if you're using one cloud provider, maybe there's a desire to have the flexibility to be portable, to maybe run in a hybrid fashion. And the problem with these public cloud providers is that you can use Kubernetes and you get an upstream Kubernetes experience, but you have to use these adjacent services which are not always portable, whereas Platform 9 offers the adjacent services from the Kubernetes catalog. So two major differences, I would say three major differences. Runs anywhere, has an SLA that's consistent, and because we are focused on Kubernetes, unlike some other public cloud services. And thirdly, the surrounding technologies around Kubernetes that a lot of customers desire, for example, Prometheus, for example, Istio, for example, tracing, and others, we're all CNCF native around that. And those are three big ways in which we're different from public cloud providers.
Great, thank you for that. Our next question, what are typical problems you solve in large-scale Kubernetes production deployments?
So I think I'd maybe give you two or three. There's many, but I'll give you two or three problems that are most common. The first one is upgrades. One of our well-known companies in the Bay Area, I won't name them because this is sensitive, they're running 1,200 nodes of Kubernetes on premises, and they made a very big bet on Kubernetes 2.5 years ago. And it was a founder CTO level bet, and they made that bet on Kubernetes. And they have gotten to the point where they're running 1,200 nodes of Kubernetes. So by all means, you'd consider that a success. But here's the rub. They're running on version 1.6. For those of you who are aware, I mean, the latest version of Kubernetes is around 1.13. There's a newer version coming out soon. They're 7 versions behind. They're 18 months behind where Kubernetes is. And they're really struggling to upgrade because of all the reasons that I mentioned. If you fall off the Kubernetes upgrade track, it becomes progressively harder to upgrade and get back on track and can be disruptive to the end users. So upgrades are a major challenge for Kubernetes, especially once you get to scale. You really need to have your operational tooling and down to a science. And essentially, if you think about it, that's a big part of what we do. The second one is resolving outages. There are real scenarios. We are the core contributors behind etcd ADM, which is the Kubernetes SIG is cluster lifecycle SIG, and the Kubernetes community is incorporating that as a standard way to manage etcd. etcd is a stateful component of Kubernetes. So when you're running highly available Kubernetes clusters, you need etcd to be truly available. If there's a problem with etcd, your Kubernetes masters cannot be reliable. If you lose a master, you lose a Kubernetes etcd node, you're effectively lost that master. And so you need to have the operational tooling around managing etcd. It's just one example of many components of Kubernetes that you need to instrument so you find problems, and then have automated runbooks and operational procedures to resolve those problems. And the nature of these problems keeps evolving as new versions of Kubernetes come along. So it's a full-time job to keep up with that, right? And to maintain those runbooks, and you shouldn't expect that to just work and not happen, because when you're running in production, there will be a day at 3 a.m. in the morning when etcd wedges, and that's just one example. So instrumenting the stack, including components like etcd, and having probes where we can detect a problem, having those probes be kept up to date as new versions of Kubernetes are being released into production, and having recipes and operational runbooks to resolve those problems is what I mean by machine operations. So upgrades and that are, I think, the areas of the highest value, and those are the things that are needed to support Kubernetes at scale in any organization.
Yeah, this is Jay too. I'd add to Suresh's point on upgrading. We do sort of see this sort of the long-term support factor, LTS. We've sort of seen this with Linux distributions. We've seen it with OpenStack. And I think it's now happening with Kubernetes. And basically, some organizations want the latest and greatest features, the absolute latest release that has the newest features that they might be able to put to work. Whereas other organizations are more focused on stability and basically a slower cadence. So there's not currently an LTS Kubernetes, but I think there is that sort of demand in the market for both, sort of the latest and greatest and the stability. And depending on where the organization is, or maybe within an organization, there's typically demand for both of those.
Great, thank you. Next question, how does Platform 9 differ from Pivotal?
So Platform 9's Kubernetes service has been in production since Jan of 2017. We have several customers who are happy to speak with you in terms of their experience with the service in production for years now. And we're a pure play Kubernetes solution. So Pivotal has Cloud Foundry, and they had an opinionated view of PaaS. And in reality, what happened is that Kubernetes has disaggregated the notion, containers and container orchestration and Kubernetes have disaggregated the view of PaaS that existed for, I would say, from 2010 to about 2015 or so. So in contrast, we are a Kubernetes first. Kubernetes is our core flagship product. We have customers who've been in production with our service. It is a service that doesn't require a lot of professional services. So the economics are dramatically better than Pivotal. We have some customers who have worked both with Pivotal and Platform 9, so I'm happy to maybe have our customers speak to you about their experience having worked both with Platform 9 and Pivotal and why they switched over to Platform 9.
Great, thank you. Why should I choose a managed service instead of doing it myself? After all, Kubernetes is open source.
It comes down to when you're running Kubernetes at scale, in any organization, when you're trying to support Kubernetes and you're saying that, look, this is no longer something that we're playing with or trying or experimenting and thinking about a new way for us to build and orchestrate our application stack, you will need an SLA. Somebody has to provide that SLA for the organization to be able to run it in confidence. And that SLA can be provided by an internal team, or it can be provided by a managed service. Regardless of who provides it, I think we should learn from the experiences that the community has had with open source technologies in general. If you look at systems like OpenStack and Hadoop, what people have realized is you cannot really provide an SLA without really having an operational infrastructure and the investment it takes in building that operational infrastructure at scale. So there's two ways of doing it. You invest significantly, and this is often the area where many people get surprised is they expect Kubernetes to be easy at scale, and it isn't. And then they find that they're underfunded and they don't have the headcount and the operational tooling needed to run Kubernetes at scale. So essentially, a managed service like Platform 9 is using machine operations, exactly what the public cloud is using internally. And we're providing those machine operations, and you should think of this as a way to augment the ability of any internal IT ops team to truly provide that SLA to the broader organization in a very cost-effective and time-effective manner. It's cost and speed.
Thank you. And Suresh, this next question is for you. Platform 9 pricing is not posted on the website. Is there any way to get this information without speaking with a sales representative?
It's a great question, and I'm a former developer, so I know exactly where that comes from. We're about to launch something that we're really excited about. It's going to be our biggest development of the year. Unfortunately, I can't tell you, but in May, at KubeCon in Barcelona, we're going to be launching something that we're very excited about, which will be a truly self-serve experience, and where you can use Kubernetes and try it, and there'll be a truly free experience as well. Today, the stack that we are running in production, the cost associated with that is higher than what allowed us to offer a true free experience. So this is based on a third-generation internal operating machine operation stack, and that is going to be available in a couple of months at KubeCon Barcelona. So there is a way, and it's coming soon. But today, we do require you to pick up a phone, or we require to have a conversation because of the costs on our end in providing these machine operations. But it's something that we understand very well, and we are investing in precisely for the reason you asked that question.
Great, thank you. And next question. Hybrid does not only mean multiple cloud providers, but also different infrastructure. How do you manage, let's say, Kubernetes on DC1 and VMware on DC2?
That's a great question. So Platform 9, as I mentioned, it's an as-a-service architecture. In other words, there is a central management plane that is providing those machine operations to these clusters everywhere. And from that central management plane's point of view, whether it is DC1 or DC2 or AWS and Azure, it's just a source of infrastructure somewhere. So you get in the Platform 9 console on the top right, you can define different regions. These regions could be DC1 and DC2, or a VMware and a bare metal environment, or an on-prem environment and a hybrid cloud, public cloud environment, or an Azure environment and an Amazon environment. You can define any number of regions that you want. You can deploy clusters anywhere. And so that's actually a big part of the draw, is saying by having a centralized machine-operated way to run these clusters, you can now truly get a consistent, unified, global way of managing infrastructure anywhere and consuming that using technologies like Kubernetes.
Great, and the questions keep coming in, so here is another one. Deployment-wise, can we have Platform 9 deployed in various CSPs like AWS, Azure, and on-prem?
Yes, so that is fully supported. We today have support for the big three clouds. That's AWS, Azure, and Google. And on-prem environments include bare metal, VMware, and OpenStack. And you can run any combination of these. We have, I think, a couple of customers requesting us for IBM and Oracle, and it's extensible, so we're going to add support for any cloud provider that a customer needs. So from our point of view, we want to be Switzerland with respect to your choice of infrastructure, whether you're using cloud versus on-prem, whether you're using on bare metal versus on VMs. That's a choice that we want our customers to make. We want to provide the same experience regardless of where that is running, and that is a highly reliable, scalable, machine-operated Kubernetes experience.
Next question. Is VMware required for on-prem Platform 9 support?
No, VMware is supported but not required. So VMware is typically required by, a lot of enterprise, for example, the Fortune 500, have deployed VMware and have been running VMware for 10, 15 years. So often they have it's not uncommon to see something like a 50,000 core VMware environment. And for them, we support VMware, but VMware is not required. A lot of our younger customers actually deploy us on bare metal. The prerequisites there are you need to have servers and you need to have Linux. We support every major Linux version out there. And you need to have power and cooling and network and cable. You don't need to know anything about virtual machines. You can run containers, Kubernetes on bare metal without VMs. You can also choose to run it if you want on VMs using Platform 9's OpenStack solution, where again, you don't need to know anything about KVM or OpenStack. It's a service, machine operated. All you need to know is Linux, and you need to have server infrastructure that you can run it on.
Great, thank you. Can you give a little more technical detail on machine operated, trying to get an understanding of how that works?
Yeah, I think this is essentially how the public cloud works internally. So if you step back and think about it, how do you think you can go to Amazon or Azure or Google, and you can get a broad range of services that kind of just work, right? I mean, broadly. GKE, for example, how does GKE work? Why is it that you can go in and just spin up a cluster, and the clusters are fairly highly available in GKE? We've tested extensively on the public cloud, so I can tell you that the GKE experience is fantastic. How does that work? And why is it so hard to run that same kind of experience within an enterprise or within an organization using other infrastructure? And the insight we had is that under the Kubernetes stack or under the EMR stack or the RDS stack in AWS, under any of these service layers is actually a machine operations layer that they call the cloud fabric. And these fabrics are broadly responsible for four major functions. How do you deploy a stack? Like Kubernetes is a stack, Hadoop is a stack, SQL is a stack, VM orchestration, EC2 is actually a stack within Amazon. How do you deploy? Then how do you instrument it so you can monitor for problems preemptively, proactively, and you can tell when there's a problem and you can tell who else is going to be affected by that problem? So you can make sure that the vast majority of customers don't hit a problem because you find a problem in one customer, in one cluster, and you now know who else is going to be impacted by it, and you have the automation then needed to develop a fix and roll it out to the rest of the customer base without them being impacted by it. So deploy a stack, instrument a stack to detect problems, have a way to roll out changes like fixes and patches and security issues and new versions in a non-disruptive fashion to a broad range of environments. And how do you troubleshoot with human intelligence in the worst case scenario? That is what we call the machine operations layer. Those are the four major functions that are involved. And the public clouds, I think, are the ones that have pioneered these concepts. But they obviously only offer that to you with their services and with the consumption of their infrastructure. And the central idea behind Platform 9 is, why is that operating model not available for DevOps teams and IT ops teams to use with any infrastructure of their choice? And that's essentially what we do, is we provide that core capability via our management plane, which you can then run on any hardware, any infrastructure, any combination of cloud and infrastructure, and with your choice of stacks, such as Kubernetes and Prometheus and Istio and Jaeger and so forth. So that's the idea. Central idea behind Platform 9 is to help customers drive more cloud value and lower costs and do more with less by taking advantage, augmenting their IT ops teams and DevOps teams with our machine operations capability.
Great. We have time for a couple more questions. How many commits have you done so far to open source version of core Kubernetes?
We measure contributions. It's a great question. We measure contributions in two ways. I don't know the exact answer to that, so I'd like to come back and happy to clarify if you send me a note on LinkedIn or otherwise. But I believe it will be in the several tens to core Kubernetes contributions upstream. But we've also been contributing entire new modules that we've developed to the Kubernetes community. For example, etcd ADM is now being incorporated into the Kubernetes core cluster lifecycle SIG, and that came from Platform 9. There is another one which is coming soon. It's called ClusterKit, which composes etcd ADM and Node ADM. Node ADM is another tool that's exactly like etcd ADM, which we are open sourcing. And again, the cluster lifecycle SIG is taking that. The Azure provider for the cluster lifecycle was actually developed by Platform 9. So we're contributing in two ways, both in terms of patches and updates to core Kubernetes, but also in terms of contributions to the community of modules that we've developed as part of our machine operations capability. So that's the way in which we contribute to the Kubernetes community, and you can expect these to be ongoing.
Great, thank you. And this will be our final question, and it's for Jay. What are companies doing as they migrate away from DIY and move towards cloud services for their application development and deployment?
Yeah, well, I think a Kubernetes distribution might be considered closer to the DIY approach, similar to the way you would take a Linux distribution and use it for your own purposes. And while we've seen that get traction with Linux and OpenStack, I think there's just as much interest among enterprises and service providers in managed services that include more than just containers or Kubernetes or serverless, but actually a combination of them, all of which we discussed sort of in that spectrum of abstraction. And then this also sort of relates to the last question and Suresh's answer in terms of, Kubernetes is not just one project. It's a collection of components, and there's a very important parts like Helm, Prometheus, etcd. It's a full ecosystem of projects that sort of contribute to a lot of the objectives that I think cloud native software is looking to solve.
Well, thanks so much. We appreciate all the wonderful questions that came in. That concludes today's webcast. As a reminder, the on-demand replay will be available on On24 soon. On behalf of Platform 9 and 451 Research, thank you so much for attending, and have a great day.